Hey guys, welcome to just some clarifying notes. I want to make sure that we got all of this out of today. So I've got all my pens, I've got my whiteout. Okay, so these are just soil clarification notes. We just want to make sure that we get everything in. And today is 10/28/20. All right, so we just want to make sure that once again, this is like at this point we should understand this information, right? And so we got a few things. We're just going to go topic to topic. The first is soil formation. Okay, so first of all, when we get soil formation, how is it affected, right? So what is it affected by? And the first thing that we'll talk about quickly is temperature. I'm not going to write out temperature, I'm just going to write TEMP. And when we talk about temperature, a few things can happen. So we can have obviously high temperatures, and if we have high temperatures, right, we can have, more microbes, right? More microbes. And then this means decomposition. And then this will increase soil formation. We can have low temperatures, depending on where we are. And if we have low temperatures, obviously, we're going to have a decrease, right, in decomposition. This would be an increase. I'm just going to put that over here. Okay, sorry about that. A decrease in decomposition, and therefore we have a decrease in soil formation. All right, because your little microbes aren't decomposing as much, creating good soil there. But on the other hand, in some areas we can have an increase, right? An increase in weathering of rocks. So the breakdown of rocks going from a rock to more of a soil. An example here would be your freeze thaw, right? When we talk about ice and water getting into cracks, it turning into ice and freezing, thawing into water. This creates cracks which can break off rocks. And so what happens then if we get weathering of rocks, we can get an increase in soil formation. So we've got temperatures high and low. We can also have areas where we get a lot of rain, so precipitation. Precipitation can lead to humidity. And we can have, once again, high precipitation and humidity. And if we have high precipitation and humidity, we typically get an increase in decomposition, right, of our organic materials. And if we have an increase in decomposition due to our organic materials, we can have increase in soil. We also, with a lot of precipitation, we can get an increase in weathering, right? And if we get an increase in weathering, an increase in decomposition, we get an increase in soil formation. All right, we can have low precipitation. If we have low precipitation, we just get a decrease in all of the above, right? A decrease in decomp, weathering, and soil formation. So think of something that's very dry and arid, right? If we have low precipitation and low humidity, we don't have a lot of decomposition or weathering happening. We probably have a lot of erosion taking place, and with that erosion, soil loss, okay? Another thing I wanted to go over to make sure we understand is biotic and abiotic factors. So we've got soil formation, and then let me see, we've got B, which is biotic. When we say biotic, we mean living. So anything that's living would be considered biotic. So our organic matter, our humus, our microbes or microorganisms, right? Bacteria. We've got animals like worms. We've got plants or roots. We've got fungus. We've got the decomposers, right? So anything that's kind of living, we would consider a biotic factor. Anything that's not living is an abiotic factor. And different ecosystems, non-living, right, have similar, but once again, different, right, biotic and abiotic factors. It's knowing that one is living and one is not living. So for our soils, we've got our clay, our sand, and silt, like water. We've got our nutrients, right, our NPK, rocks, right? These are all non-living factors. Then another important thing to understand that we've talked about is nitrogen in our waters, right? So nitrogen in our water. We talked about nitrate specifically, giving blue baby syndrome, where we get a decrease in oxygen and babies literally turn blue. But how does the nitrogen get into our water for this to even happen, right? And so two big ones, right? We've got fertilizers, right? So our agriculture. And then what's another one? Animal waste. Right, so how does nitrogen get into our water? Fertilizers and animal waste. If we're talking about phosphorus in our waters, how does phosphorus get in? Well, once again, fertilizers from agriculture again. Oops, sorry guys, let me move the camera. All right, so fertilizers in agriculture, but we get a lot of weathering from rocks, right? So when rocks start to weather and break down, we're going to get phosphorus in our waters from our rocks, and then animal waste. Now, in this particular section, we used models, right? We used models to explain our biogeochemical cycles, and models are simplified versions of reality, right? We try to simplify things down, and they can be used to understand how a system works. And predict how it will respond to change. That's a big one, right? A lot of our computer models are helping us to predict, how things are going to respond to change. This is why when we see hurricane models, we can, there's always numerous different computer-generated systems that show a hurricane path, numerous computer models, and we're trying to predict where it's going to go to help people out. So just realize when we talk about models, obviously we can have computer models, we can have two-dimensional models like our handwritten biogeochemical cycles. We can actually make physical models. Sorry, physical. There we go. There we go. All right. In this unit, we've also talked about percent increase. Hopefully we remember percent increase. And I'm just going to give you the equation, right? Percent increase, if we're looking at increase or decrease, right? It doesn't really matter. if we're looking at that percent increase or decrease, we want to take our final number that we get minus our initial, whatever that might be, and divide it by the initial. Okay, so we got to subtract those first, so we're going to put those in parentheses. If the initial number is negative, we're going to just take the positive, the absolute value, and then we just multiply by 100 to create a percent. And we did see some percent increase problems within this unit, so just make sure we have that in mind. Okay, and I think that's it. If you have any questions, please let me know, but those are some just big clarifying notes. We want to make sure that we got those out of what we've done in our PowerPoint, our slideshow. When we're thinking about a lot of this stuff from the slideshow that we just saw today, once again, thinking about advantages, disadvantages, or cause and effect. All right, thank you so much.